Hello. In this video tutorial, we're going to be looking at skills practice 14.1, series circuits. Please remember to pause or rewind the video as needed. Read along with me, please. In a series circuit, current follows only one path from the positive to the negative end of the battery. Total resistance is equal to the sum of the individual resistances. Okay, so let's actually write an equation that would help us out. The resistance in series, the resistance of resistors connected in series would be the sum of the individual resistors. So R1 plus R2 plus ... Now the plus ... means you're going to continue adding the resistances for however many resistors you have in series. If you have 15 resistors in series, you would add the resistances of all 15. Now, down below, you're also going to need to use Ohm's law. So when you see amps, that is connected to current. If you see volts, that's connected to voltage. And if you see ohms, which is the symbol omega, that is connected to resistance. So I equals V divided by R. We're going to be using that. Do keep in mind, we're going to use another version of the Ohm's law equation to find the voltage drop. So to find the voltage drop, solve for V. And the voltage drop across a resistor equals the current times the resistance. So V equals I times R across any resistor. All right, so we're going to be using these to go through the following practice items. Let's begin. Number one, use the series circuit pictured to the right to answer questions A through E. A, what is the total voltage across the bulbs? Well, the total voltage is going to be 6 volts. What is the total resistance of the circuit? Well, we're going to be adding those two together. So the total resistance would be 2 ohms. Part C, what is the current in the circuit? Well, current is equal to total voltage divided by total resistance, or 6 volts divided by 2 ohms, which is 3 amps. Okay, so we have 6 volts, 2 ohms, 3 amps so far. Now I'm going to go to my actual graph. I'm going to mark up something here. I'm going to mark up the fact that we have 3 amps going across this light bulb here. And we have 3 amps going across this light bulb here. Because current in series circuit is exactly the same anywhere. So we had 3 amps coming from the battery, and that 3 amps is going to pass across. By the way, we're doing part E right now. We're drawing the path of the current. So the current of 3 amps is going to go from the positive end of the battery across each light bulb like this, and find its way back to the negative side of the battery. Okay, for part D, let's go back and look at part D. We're calculating the voltage drop. So remember, to do voltage drop, we're simply doing I times R for each resistor. Now, if the resistors are the same, we only need to do one calculation. If the resistors are different, we do a V equals IR calculation for each different resistor. So I noticed that the resistance is the same, 1 ohm for each one. So I'm just going to do this one time. The voltage drop across the resistor, V equals I, which is 3 amps, times 1 ohm. What that means is there's 3 volt drop across each resistor. Let's go to the circuit diagram and let's comment on the following. you start with a positive of 6 volts on the positive side of the battery and 0 volts on the negative side of the battery. Okay, so we have 6 volts of potential right here before we even get to the first light bulb. Now, across the first bulb, we drop 3 volts. So that means 6 volts on the left side, 3 volts on the right side, because we have subtracted or dropped 3 volts of potential on that first light bulb. We drop another 3 volts across the second light bulb resistor, and you are down to 0 volts over here, which makes sense because that's connected to the negative side of the battery, which is 0 volts. Question number 2. Use the series circuit pictured to the right to answer questions A through E. Well, it's pretty much the same problem as number 1. You start with the total voltage of 6 volts. The total resistance this time is going to be 3 ohms. The resistance is greater, which means the total current, which is voltage divided by resistance, is going to be a little less. 6 volts divided by 3 ohms is now 2 amps. We have 2 amps of current here, 2 amps of current here, 2 amps of current here, 2 amps of current here. And if we draw the current in that circuit, it's going to go again in one path, all the way from the positive to the negative end of the battery. Okay, so part D, what is the voltage drop across each light bulb? Now, each light bulb is the same 1 ohm resistor, so we're just going to do this calculation once. V equals I times R, or 2 amps times 1 ohm equals 2 volts. So we're going to be dropping 2 volts on each light bulb. What that means is I start with 6 volts on the positive side, 0 volts on the negative side. So at this point here, I have 6 volts. At this point here, I've dropped 2 of them. I dropped 2 volts across each light bulb. So 6 minus 2, I'm down to 4 volts here. I drop 2 more, I'm down to 2 volts here. I drop 2 more, I'm down to 0 volts, which is connected to the negative side of the battery, which is 0 volts. Okay, part 3. What happens to the current in the series circuit as more light bulbs are added, and why? Well, when we added more light bulbs in the circuit, we added more resistance in the circuit. The voltage was the same, but more resistance means less current. So let's comment on that real briefly. More light bulbs added means more resistance. More resistance equals a decrease in current. And it decreased from 3 amps to 2 amps. What happens to the brightness of each bulb in series as more bulbs are added? Well, brightness, bulb brightness, bulb brightness relates to the current passing across each bulb. When more bulbs are added, the current decreases. This means the bulbs will be dimmer. All right, page 2 at the top, number 5. Use the series circuit pictured to the right to answer questions A, B, and C. Now you'll notice you have a 6-volt battery, right? Same 6-volt battery, but this time your resistors are different. Well, remember, we're going to add them up again. So what is the total resistance this time? Well, the total resistance this time is going to be 3 ohms because 1 plus 2 is 3. Now the current in the circuit is going to be using Ohm's law the same way. So 6 volts divided by your total 3 ohms is 2 amps. So I have 2 amps of current here, 2 amps of current here, and 2 amps of total current coming from the battery. Now, even though it didn't ask me to, I'm going to draw the current going through the circuit again. The current is the same 2 amps everywhere along the way. All right, what's the voltage drop across each resistor? Well, the voltage drop across the 1 ohm resistor is going to be 2 amps times 1 ohm, which is 2 volts. The voltage drop across the 2 ohm resistor is going to be the same 2 amps times 2 ohms, which is 4 volts. Okay, again, if we take the time to look at the voltage drop in various spots, we start with 6 volts on the positive side and 0 volts on the negative side of the battery. That means we have 6 volts going into the first resistor, but we have just dropped 2 volts here. So now we're down to 4 volts in between the resistors. We drop a total of 4 volts across the bigger resistor. Therefore, we're down to 0 volts on the other side. Question 6. Use the series circuit pictured to the right to answer questions A through E. What is the total voltage of the circuit? Well, go ahead and add those two, and the total voltage is 12 volts. Again, you have 2 resistors in series, so go ahead and add them. The total resistance is 4 ohms. Pretty easy so far. The current we'll again find using Ohm's law. So 12 volts divided by 4 ohms equals 3 amps. So I have 3 amps of current coming from the battery. And if I trace the current for part E, it's going to look like this, going across both bulbs back to the battery. Okay, so I've got 3 amps of current there. I have 3 amps of current across each bulb as well. Okay, what is the voltage drop across each bulb? Well, they're the same voltage, or the same resistance, excuse me, so I need to calculate this once. Voltage equals I times R, so it's going to be my 3 amps times my 2 ohms equals 6 volts. All right, so again, we start with a total of 12 volts. Oops. We start with a total of 12 volts before we get to the first bulb. 0 volts on the negative side. We just dropped 6 volts, so now you're down to 6 volts in between the bulbs. Then we drop another 6 volts and you're down to 0 as you approach the negative side over here. Number 7, use the series circuit pictured to the right to answer questions A, B, and C. Consider all resistors to be equal. Okay, what is the resistance of each resistor? Well, to find the resistance first, you need to find the total resistance first. So find total resistance first. Now you can do that using Ohm's law. Remember how Ohm's law is I is equal to V over R. Well, let's swap those two. And total resistance is now V over I. Okay, well, the total voltage is 3 volts divided by the current of 0.5 amps. Well, that would be 6 total ohms. Now that's total ohms. Keep in mind you have 3 equal resistors. So that means the resistance of each one would be 2 ohms. I take the 6 and divide it by my 3 equal resistors, and I will have 2 ohms on each one. So this is a 2 ohm resistor. This is a 2 ohm resistor. That is a 2 ohm resistor. Okay, what is the voltage drop across each one? Well, they're the same resistance. So voltage drop would equal I times R, or 0.5 amps times 2 ohms, which is 1 volt. Okay, on the diagram, show the amount of voltage in the circuit before and after each resistor. Well, this is what we've been doing. 1.5 plus 1.5 would mean 3 volts before the first resistor, right here. After the first resistor, you've dropped 1 volt. So we're going to drop 1 volt each time. So 1 volt, 1 volt, and 1 volt of potential drop each time. Okay, so that means if I drop 1 volt, I'm down to 2 volts here. If I drop another volt, I'm down to 1 volt here. And if I drop 1 more volt, I'm down to 0, which connects us to the negative end of the battery, which is 0 volts here. Number 8, use the series circuit pictured to the right to answer questions A through D. What is the total resistance of the circuit? Add them up. Total resistance of the circuit in this case would be 6 ohms. Just go back to question number 7. Sorry, I forgot to. Let's highlight our answer. We see each resistor was 2 ohms, and the voltage drop on each one was 1 volt. Okay, sorry about that. And then part A, we had a total sum of 6 ohms. The current in the circuit, we use Ohm's law to figure out. So voltage divided by resistance would be 9 volts over 6 ohms, which reduces to 3 over 2, which reduces to 1.5 amps. Okay, that would mean 1.5 amps coming from the battery, 1.5 amps across resistor 1, resistor 2, and resistor 3. Whoops. Okay, so what's the voltage drop across each resistor? Well, you have 3 different resistors, so you have to calculate it 3 times. So I'm going to call this resistor 1, resistor 2, and resistor 3. So the voltage drop on 1 is going to be 1.5 amps times 2 ohms, which would be 3 volts. The voltage on 2 would be 1.5 amps times 3 ohms would be 4.5 volts. And finally, the voltage drop across the third one will be 1.5 amps times 1 ohm, which would be 1.5 volts. Okay, so if I mark this up, it would be starting with 9 volts here before the first resistor. After resistor 1, you've dropped, what do we get? 3 volts, 4.5 volts, 4.5 volts, and then 1.5 volts. Okay, so after the first resistor, we've dropped to 6 volts. 9 minus 3 is now 6 volts. Now we drop 4.5 more, we're down to 1.5 volts. We drop the final 1.5 volts here down to 0 volts. So in part D, it says, what is the sum of the voltage drops across? Well, the sum of the voltage drops would add up to 9 volts, right? This is the same as the total voltage on the battery. Finally, number 9. Use the diagrams to the right to answer questions A, B, and C. Part A, how much current would be measured in each bulb if each had a resistance of 6 ohms? All right, so here we go. This is 6 ohms. This is 6 ohms, right? This is 6 ohms. This is 6 ohms. So each one is a 6 ohm resistance. So how much current? Well, do your Ohm's law. So I'm going to do circuit A and circuit B. We'll do them separately. So the current on A would be 6 volts divided by 12 ohms. You have to add those together, right? And we get half an amp. The current on B, I'm kind of running out of room here, put it wherever you can put it, would be 12 volts, right? 12 volts over 12 ohms, or 1 amp. Okay. Now part B, how much current would be measured if each light bulb had a resistance of 12 ohms? All right, so now each bulb measures 12 ohms. Right, add them together, you have a new total resistance. Okay, so current on A would be 6 volts divided by 24 ohms, which is a quarter of an amp. The current on B would be 12 volts divided by 24 ohms, which is half an amp. You'll notice that in both cases, the current increased when the voltage increased. Okay, so in circuit B has twice the current as circuit A because current B has twice the energy or twice the voltage. However, you'll also notice that by doubling the number of bulbs, right, you double the resistance. So adding more bulbs adds more resistance, means when the bulb's resistance doubles to 12 ohms for each one, the total resistance is now 24 total ohms, which means the current cuts in half for each circuit. Okay, so let's summarize that for part C. What happens to the amount of current in each circuit as the number of batteries increases? Well, as the number of batteries increases, increasing the number of batteries increases the voltage, which increases the current in each circuit. I hope you found this tutorial to be helpful. Again, please remember to pause or rewind as you need.